Welcome back, everyone. Today, we're going to implement our fetchEmployee method using Criteria API. So earlier, we implemented our fetchEmployees method using JPQL, where we dynamically applied filters like employee name and department, and also handled pagination using offset and max limit. But today, we're going to rewrite the same logic using the Criteria API. Commenting out our existing JPQL code. Okay, first step, let's create a CriteriaBuilder. Alright, now that we have our CriteriaBuilder, the next step is to create a criteria query of type employee. Why employee? Because we're going to fetch a list of employees, and we want the result mapped directly to the employee entity. Great! Now we need to tell Criteria API from which table or entity we want to fetch data, and we do that using a root object. Alright, next step, let's create a list to store our dynamic filter conditions. Make sure you import the predicate class from the jakarta.persistence.criteria package, not from java.util.function, okay? This is super important. Okay, now, let's add our first filter. Check if employee name is not blank. If it's present, we'll create a predicate to filter employees by name and add it to our list. This equal method compares the employee name column with the value passed in the request. Okay, next, let's add a condition for the department field, but only if it's present. Just like we did for employee name. Alright, now we want to fetch all columns of the employee. For that, just call the select method of the criteria query and pass the root object. Next, we need to apply our filtering conditions, the predicates we created. See, the criteria query provides a where method that accepts an array of predicates. It automatically combines all of them with an and condition, so all filters will be applied together. Since we have our predicates stored in a list, we just need to convert it to an array and pass it here. See my screen, I'm doing the same here. Okay, next step, we execute this criteria query. Call the createQuery method on our EntityManager, passing in the criteria query object. Next, set the offset. Next, set the maximum number of records we want per page, the page size. And finally, let's fetch our results. Awesome, our paginated filtered list of employees is fetched. Here's a quick recap of what we did. First, get the criteria builder from our EntityManager. Then create a criteria query of employee, telling JPA, hey, I want employee objects back. Next, define the root of employee. This points to the employee table, so Criteria API knows where to look. Next, build dynamic filters by creating predicates for employee name and department. Next, we tell our query to fetch all columns of the employee entity. Then apply the filters using where method of criteria query. Alright, we've fetched our paginated list of employees. Nice. we also need the total employee count that matches our filters. This means running a separate criteria query that returns just the count, so we know how many pages we have in total. Since we need a total count in addition to our paginated list, we have to build a separate criteria query that returns a long value. To avoid duplicating all that predicate building logic, let's refactor our dynamic filter section into its own helper method. Okay, now instead of rebuilding those filters by hand, let's call our new helper method, getPredicates, to generate the list of predicate objects for our conditions. Alright, let's build our count query next. We only need a single number back, how many employees match our filters, so we tell the Criteria API to return along. This tells JPA, hey, I'm expecting one long result. Next, we need a fresh root object for our count query, because it's a separate criteria query instance. This tells JPA, for this count query, fetch data from the employee entity. Next, we need to create the filter conditions for our count query just like we did for the data query. Instead of rewriting them, we'll call our helper method getPredicates, but this time pass in count root so it builds the correct predicate instances for the count query. Alright, now it's time to select our count column, since this query's job is just to give us the total number of employees matching our filters. Remember, in our previous video, we already covered how to build a count expression. So let's quickly recreate it here by calling the count method on our CriteriaBuilder. This gives us the SQL equivalent of count asterisk. Next, let's apply our filter conditions to the count query. We use its where method and pass in our array of predicates, just like we did for the data query. Alright, final step for our count query. Let's execute it and grab the total number. Okay, we're all set. Our data list and total count are ready. Now let's return the response. Now you might be wondering, why are we creating two separate criteria query objects? That part is clear. We're running two different queries. One for fetching employee data, and another for getting the total count. But your next question might be, why are we recreating the root and the predicate? Can't we reuse them? Here's the key point. When you create a root object, it's tied to the specific criteria query it was created from. Similarly, the predicate is also bound to that root, which means it's indirectly tied to the same query. So when you create a new criteria query, like the one for counting, the previous root and predicate won't work, because they belong to a different query context. That's why we create a new criteria query for count. Create a new root object from that query. and regenerate the predicate using this new route. So yes, it's necessary and correct to recreate them when switching to a new query. Alright, now let's start the application. Alright, let's hit the API now. I'm going to test it with page 1. Awesome. See this? We got the response with 4 records in this page, and the total pages is showing 14. Now let's quickly verify this with our database. And yes, we've got a total of 54 employee records in the table. So it's working perfectly, because 54 records divided by 4 per page gives us 14 pages, right on point. Alright, now I'm hitting the API again, this time with page 2. Perfect. We received the next 4 employee records as expected. Okay, now let's switch back to IntelliJ and focus on the console logs. See here, 2 queries are being executed for each request. One query is fetching the actual employee data for the current page, and the second query is fetching the total count of employees that match our dynamic filter conditions. Okay, next, let's hit the API again, but this time we'll filter by department. I'm passing department developer in the request. Great. See, we got the response, and the total pages is showing as 7. Now let's switch to dbeaver and check our employee table. See, we have 25 records in the developer department, and since our page size is set to 4, 25 divided by 4 gives us 6 full pages plus 1 more with remaining data, so total 7 pages. Alright, now let's switch back to IntelliJ and check the console logs. See that? Both queries ran successfully. The first one fetched the list of employees from the developer department. The second one counted how many total employees matched the same condition, and we used that to calculate the total pages for pagination. Alright, next let's test with 2 filters: Department Developer and Employee Name Vikas Mehta. Awesome, we got the filtered response. Now let's quickly switch over to IntelliJ and check the console logs. See that? Both queries, the one for fetching employees and the one for counting, they both include filters for employee name and department. Alright, let's quickly wrap it up. In this video, we learned how to build dynamic paginated queries using the Criteria API, with filters like employee name and department. We also handled total count queries separately and cleanly using reusable predicate logic. If you found this helpful, hit that notification bell, like the video, share with your friends, and of course, don't forget to subscribe to the channel. Thank you so much for watching. See you in the next one.